All right, here's where we're going to start with some new stuff. So we're going to talk about rules of inference. And what rules of inference are logical transform rules that we can use to infer a conclusion from a premise of our argument. Okay? So what we assume in a logical proof, that's what we call our premise. And what we're trying to justify is our conclusion. And using this set of rules, they can be used to infer any valid conclusion if it is possible for us to conclude such a thing. So one rule of inference, and the first one is going to be modus ponens, and this is stated below. So it says, if P implies Q, given P, right, therefore Q. So the statement says, if P implies Q is true, cool, and P is true, therefore Q is true. And we read this like triple dot symbol right here. We read that as therefore Q. So let's do a verbal example of this, of an argument that uses modus ponens. Okay, so let's say, if it is raining, then the ground is wet. I believe that is true. It is raining. Therefore, the ground is wet. Say, this is our example of modus ponens, okay? So let's take a look at making a truth table for this, and we'll see that given P is Q true and P implies Q is true and P is Q, we're always going to get that Q is true. So let's take a look. So here we're making a modus ponens truth table. So I've got my P's, find your P's and Q's. I can't believe that's the first time I'm making this joke. Okay, true implies true is true. True implies false is false. False implies true is true, and false implies false is true. P is true. False, false. True, false, true, false. Okay, so I'm looking for where I have that P implies Q is true and P is true together. That's only right here. That's only right here. That's the only place where they're both true, because this is an F. I just didn't draw it very well. Well, as you can see, Q is also true at this time. So that's how we proved our new rule of inference using a truth table. And here I have the answer all typed up, and I bolded the row that proves it's true. Let's talk about another rule of inference. This rule of inference is modus tollens. I will misspell this so much. Okay, and modus tollens says P implies Q, not Q, therefore not P. Okay, so if P implies Q is true and Q is not true, then P is not true either. Okay, so for example, we could call this a proof by contradiction. Here's a really famous one. So if Zeus is human, then Zeus is immortal. Okay, Zeus is not mortal, therefore Zeus is not human. So we'd have P being Zeus is human. I misspelled Zeus. No, it just looks funny. Q is Zeus is mortal. And then this right here, Zeus is not mortal, that'd be not P, and here we have not Q. So let's prove this as well using a truth table. I'm going to go ahead and I'm going to have P, Q, P implies Q, not Q, not P. And you could have done these columns in a little bit of a different order, but I like to start with my P's and Q's and then go down the line. So I have true, true, false, false, true, false, true, false. P implies Q, true, false, true, true. Next, I have not Q is false, not Q is true, false, true, and then false, false, true, true. So what I'm looking for is where P implies Q is true and not Q is true. And they are only true right here. And as you can see, that's the same row where I get that not Q is also true. So modus tollens works. Yay! There's the answer all typed up for you with a nice bolded start. So let's prove the following using a truth table. I wanted to give us a couple more examples using these rules of inference. So I have P implies Q, and P or Q is true, therefore Q. Cool. So let's see, I've got P, Q. I don't think that orange shows up very well. We'll try that again. P, Q, P implies Q. P or Q, and then Q. And you'll see in like the text, like after our initial conditions, it has like a double line. And some of you have managed to do that in the homework you submitted that you typed up. Typing up these truth tables in Excel or in Word is a great idea, but you can also do them by hand. I'm happy to accept them that way. But I just wanted you to know that that's what it's doing. It's separating our initial conditions from our conclusions. So I've got, let's change colors again. True, true, false, false, true, false, true, false. P implies Q, true implies true is true, true implies false is false, false implies true is true, and false or implies false is true as well. Now I have P or Q, remember, oops, that means that one or the other has to be true, so I'm going to get true, 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 false, okay? We already know what Q is. We just copy this table over here. So I'm looking for the rows where both of these, P implies Q and P or Q, have a true truth value. So that occurs twice this time. That's exciting. It occurs right here. And it also occurs right here, that both of those are true. And you can see that given both of those conditions, Q is also true. So we did our job. Here's our answer. I have bolded where it was correct. All right, this one's a bit longer because we've got 3 variables, but I think we can handle it. So if I've got P, Q, R, those are my initial conditions. I have P implies Q, P implies R, not P, therefore not Q and not R. Oof. Okay, so I have my P's. This time I'm going to do 4 trues and then 4 falses. And then for Q, I'm going to do 2 trues, 2 falses, 2 trues, and 2 falses. This is to make sure I get every possible combination. Then I'm just going to go true, false, true, false, true, false. And I did that really fast, so I'm going to check my work real quick. Looks good. P implies Q, true, true, false, false, true, 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 true. That was a lot of trues. P implies R. Remember, now I'm looking at this column. I'm going to get true. Ooh. I'm going to get true. True implies false is false. True implies true is true. True implies false is false. False implies true is true. False implies false is true. False implies true is true. And false implies false is false. Not P is false, 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 false. Wait, nope, that one's a true. I was going too quickly. True, 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 true. Now I'm looking at not Q and not R. Okay, so that would give me here, not Q is false, not R is false, false and false is false. Q is true, not Q is false, not R is true. True and false and true would give me a false. Not false, not would be true, not true would be false. So as long as these don't match, right, I'm going to keep getting false. Now I have two falses. Both those falses become trues because we're taking the negation. So then I finally have my first true value. True and true, well, that's a double false. True and false, that's a true and false, that's a false. False and true, that's going to be a false. And then false and false would also give me a true because we're taking the negation. So we can see from this table, if we look at this, here we have, this should be a true, my bad. Here we have all of our trues, but there's a problem. The problem is that whenever P implies Q is true and P implies R is true and not P is also true, that's these four rows, it doesn't always seem to be the case that we have not Q and not R, right? So this argument, because we got some falses, we didn't get all trues, this argument is invalid. And you can see that here, I have all the answers because whenever all of our stuff was true, we got some falses. That's bad news, bears. So it was an invalid argument. So here's the homework. What I'd like you to do is choose 6 of the rules of replacement. That's problem 1 in this homework assignment, but not De Morgan's modus ponens or modus tollens because I already did those. These rules are found on page 68 and 74, and I'd like to use to complete problem 2 as well.